Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2101 pertains to an ETCS, Electronic Throttle Control System, malfunction in the Honda Accord models from 2008 to 2012. The ETCS is responsible for regulating the throttle valve's position, and any malfunction in this system can adversely affect vehicle performance. The throttle body, where the throttle valve is located, is directly influenced by commands from the Engine Control Module, ECM, also known as the Powertrain Control Module, PCM. Importantly, the throttle body is generally situated between the intake air duct and the engine manifold, making it crucial for optimal air-fuel mixing. It is imperative to handle the throttle body with care, since inserting fingers into the throttle body during ignition may lead to severe injuries, as the valve can activate unexpectedly. Proper troubleshooting is essential for accurate diagnostics and repairs, allowing the vehicle to regain normal functionality while ensuring driver safety. The DTC P2101 indicates an issue with the Electronic Throttle Control System, ETCS, specifically potential failures in the throttle body, ECM, or the throttle valve itself. The throttle body is an integral component that controls the amount of air entering the engine, crucial for maintaining optimal engine performance and response. The ECM-PCM acts as the brain of the vehicle's engine management system, sending signals to the throttle body to adjust airflow. The malfunction may stem from an internal failure within the throttle body, or communication issues between the ECM-PCM and the throttle system. It's essential to thoroughly inspect these components to determine the exact cause of the error. The throttle valve, located within the throttle body, regulates air intake based on accelerator pedal inputs, making its proper operation vital to vehicle performance. There are several possible causes for the DTC P2101, primarily revolving around the Electronic Throttle Control System, ETCS. A faulty throttle body can prevent adequate airflow regulation, leading to the malfunction. Wiring issues, such as poor connections or damaged wires between the throttle body and the ECM-PCM, may further compound the problem, as they affect the communication between these components. A failing ECM-PCM can mistakenly interpret data or send incorrect signals to the throttle body, which can also trigger this DTC. Identifying these potential causes is crucial for effective troubleshooting and repair, as resolving them will restore the proper functioning of the ETCS and improve vehicle performance. Failure to address these issues may result in reduced engine performance, increased emissions, or dangerous driving conditions. Drivers experiencing issues related to DTC P2101 may notice several concerning symptoms. A primary indicator is the illumination of the check engine light, CEL, signifying a fault within the vehicle's diagnostic monitoring system. Poor engine performance can manifest as sluggish acceleration, inconsistent power delivery, or stalling, creating a hazardous driving experience. Additionally, an unresponsive throttle can occur, making it difficult for drivers to control vehicle speed effectively. These symptoms indicate the need for immediate attention and diagnostics, as they may compromise vehicle safety and operation. Prompt recognition of these warning signs may prevent further damage to the engine management system or related components, ensuring safe driving conditions. The first step in troubleshooting DTC P2101 involves turning the ignition switch to the on position, labeled as 2. It's essential to record any freeze frame data before proceeding, as this information provides insights into the vehicle's conditions at the time of the error. The freeze data may include parameters such as engine speed, vehicle speed, and accelerator pedal position, APP sensor readings, which are critical for understanding the context of the malfunction. Reviewing general troubleshooting information is also beneficial, as it may offer guidance on known issues related to this DTC. This foundational step ensures that the technician has a comprehensive overview before diving deeper into diagnostics, aiding in an accurate assessment of the problem. After recording the necessary freeze data, the next step is to use the HDS, Honda Diagnostic System, to clear the DTC. Clearing the code allows the onboard system to reset, enabling fresh diagnostics to be performed. Following the clearance, it's crucial to conduct the ETCS test found in the inspection menu of the HDS. This test assesses the throttle system's functionality by evaluating how the throttle body responds to the ECM's commands. The outcomes of this test will determine whether the issue is ongoing or if there are residual problems needing further investigation. Engaging in these preliminary steps is essential for establishing a diagnostic baseline from which further troubleshooting can progress. Following the ETCS test, the next step involves checking for pending or confirmed diagnostic trouble codes, DTCs, again with the HDS. This step is critical for determining whether DTC P2101 is still being indicated after the previous troubleshooting steps. If this code reappears, it suggests that the issue has not yet been resolved and requires further attention. Conversely, if the code does not reappear, it may indicate an intermittent failure, suggesting that the system might stabilize on its own. This testing stage is valuable for monitoring any changes in codes and emissions levels, helping to guide the technician's next steps in addressing the throttle control system issues. If DTC P2101 is not indicated, the next troubleshooting step involves performing a test drive. This drive should be conducted while ensuring the vehicle operates within the parameters recorded in the freeze frame data. Parameters to keep in mind include engine speed, vehicle speed, and readings from the accelerator pedal position, APP sensor. This approach allows the technician to replicate the conditions under which the DTC was originally logged, thus providing a clearer context for diagnostics. Observations made during the test drive can yield valuable insights into potential environmental factors or driver inputs that may contribute to the throttle malfunction. This practical step is essential for confirming the stability of the ETCS under operating conditions. After the test drive, the technician must again check for any pending or confirmed DTCs using the HDS. If DTC P2101 reappears, it signifies an ongoing issue that needs further investigation. However, if no codes are found, it may indicate an intermittent failure. This situation suggests that the current system is operational. In such cases, it is crucial to consider checking for poor connections or loose terminals at both the throttle body and the ECM PCM. These connection points can lead to interruptions in communication, triggering the DTC. Additionally, cleaning the throttle body is a recommended maintenance step, as buildup can impact performance and reliability over time. This approach helps ensure optimal functionality and minimizes the chances of future errors. In continuing with the troubleshooting process for DTC P2101, the technician should first turn the ignition switch to the lock position, also known as 0, ensuring all electrical connections are deactivated. The next critical task is to disconnect the intake air duct from the throttle body. This action helps provide unobstructed access to the throttle body for subsequent inspections or tests. It's essential to ensure that no debris or contaminants enter the engine during this process, as maintaining a clean working environment is fundamental in automotive diagnostics. Proper disconnection helps facilitate inspections of the throttle body's internal components and further tests designed to assess its performance. These measures are essential in confirming the integrity and operational efficiency of the ETCS. Once the intake air duct is disconnected, the technician should again turn the ignition switch to the on position, indicated as 2. This step prepares the onboard diagnostic system for further examination of the ETCS. Again, the technician utilizes the HDS to clear the DTC, effectively resetting the system once more. This reset is important in evaluating the throttle body's operational status accurately. This process allows for a clean slate for subsequent tests, ensuring any remaining fault codes are recorded correctly. By re-engaging the diagnostic tool in this manner, the technician can accurately discern whether the initial problem persists, allowing the technician to monitor system performance closely following subsequent tests. After clearing the DTC, the technician should execute the ETCS test once again through the HDS. This orchestrated test assesses how the throttle body and related systems respond when commanded by the ECM. Thoroughly observing the throttle valve's operation during this test is crucial, as it provides direct insight into whether the valve operates smoothly and correctly as intended. Any irregularities in movement could suggest underlying failures, be it mechanical or electronic. Should the throttle valve exhibit any sticking or lagging behavior, it could indicate dirt buildup or mechanical failures within the throttle body itself. A detailed evaluation during this test is fundamental in pinpointing the root cause of the DTC P2101 and guiding subsequent corrective actions. Following the ETCS test, the technician must visually check the throttle valve's functionality to determine if it moves smoothly. If the throttle valve operates as it should, the next step is to clean the throttle body. Accumulated carbon deposits, dirt, or grime in the throttle body can negatively impact performance, making cleaning a critical maintenance task. Once cleaned, the technician should re-evaluate the system, including rechecking for DTC P2101. If the DTC still indicates, it might be necessary to pursue further diagnostics to uncover other potential issues. However, if the valve has demonstrated smooth operation and the cleaning clears the trouble code, this may indicate that prior issues were due to contamination rather than a systematic failure. Properly resolving and maintaining these components is vital for ensuring optimal vehicle operation and performance. In a situation where the throttle valve does not operate smoothly, the technician should again turn the ignition switch to the lock position, ensuring all systems are powered down for safety. The next step involves disconnecting the throttle body 6P connector, which will allow for additional checks on the electrical connections and component integrity. Disconnecting the connector also minimizes the risk of accidental activation of the throttle body during diagnostics. At this stage, it's important to assess the state of the connector and wiring for any visible signs of wear, corrosion, or damage. A thorough visual inspection combined with electrical testing can help identify if the fault lies within the connector or wiring, which is imperative for an accurate diagnosis and successful remediation of the issue at hand. Continuing with the diagnostics, the technician should jump the SCS line using the HDS. This step helps facilitate further diagnostic data retrieval and aids in isolating potential faults within the electronic systems. Following this, the technician should disconnect the ECM-PCM connector B, which is a crucial part of the vehicle's engine management system. Isolating the circuitry between the ECM, PCM, and the throttle body can help determine if the fault lies within the control unit itself or in the communication line. This procedure is part of a methodical approach to ensure that all possible sources of the malfunction are thoroughly examined. enabling a highly detailed level of analysis that will guide the repair process effectively. The final troubleshooting step involves checking for continuity between terminal B33 of the ECM-PCM connector and terminal number 4 of the throttle body 6P connector. This electrical continuity test is crucial for ensuring proper communication between the two components. If continuity is solid, it suggests that the wiring is intact and that the circuit is functional. Conversely, a lack of continuity indicates potential wiring faults, which could be the underlying cause of DTC P2101. Assessing wiring integrity is paramount, as damaged or frayed wires can disrupt the signals transmitted between the throttle body and the ECM. This step is vital in drawing conclusions about necessary repairs or corrections, helping technicians promote overall system reliability. Upon completion of all troubleshooting and any subsequent repairs, the technician must recheck for any outstanding DTCs using the HDS. This verification step ensures that all errors have been addressed successfully and confirms the effectiveness of the corrective actions taken. If DTC P2101 or any other codes are cleared, further inspection, including a test drive, may be warranted to ensure the throttle body operates as intended under real-world conditions. Verifying that the throttle valve and associated components function correctly ensures the driver is equipped with a reliable vehicle. This conclusion step reinforces the importance of meticulous troubleshooting and repair practices in enhancing operational reliability. To help prevent DTC P2101 from recurring, adopting a regimen of preventive maintenance is essential. One effective practice is to schedule regular cleaning of the throttle body, as carbon buildup can negatively impact performance and efficiency over time. Keeping the throttle valve area clean minimizes the risk of malfunctions arising from dirt and buildup that can interfere with operation. Additionally, performing visual inspections of electrical connectors and wiring can identify wear or damage before they lead to failure. Taking proactive measures, such as these, can enhance the longevity of the throttle control system and reduce the likelihood of encountering similar error codes in the future. Consistent maintenance is key to ensuring uninterrupted functionality and optimal vehicle performance in the long run. In conclusion, addressing DTC P2101 requires a thorough understanding of the Electronic Throttle Control System, its components, and potential failings. Accurate diagnosis is vital, as this code can stem from various causes, ranging from the throttle body to the ECM, PCM, or wiring connections. Awareness of the symptoms associated with this DTC will enable drivers to seek timely assistance and drive safely. The importance of implementing regular maintenance procedures cannot be overstated, as preventative actions like cleaning the throttle body and inspecting wiring can circumvent many future issues. Immediate attention to this code is necessary to ensure driving safety and vehicle reliability. By adhering to these guidelines and methods presented during diagnosis and repair, technicians can effectively troubleshoot and resolve issues related to DTC P2101. Please like and subscribe to the channel. See you next time!